Hi there, welcome to my beer solution video. This is a video on micronaut microservices, how to create a microservice web application. The whole project can be found here, um, and this is what this video is based on. I'm not sure how familiar you are with microservices. A few years ago, typically everything was monolithic web applications, and by monolithic, everything was in a self-contained application that you deploy out. And microservices has been around for years, but over the last 5 years or so, some of the big players have taken it on board, and it's been sort of phased into web technologies better. So you have reactive front ends and you have reactive back ends. And for Java, in this application, RX Java is used to do the reactive backend work. And it's basically reactive means it's non-blocking. So it's a bit like promises asynchronous. It's something you probably want to look into. It's more like a IO thing, but it's worth researching. And typically, the difference between your microservice application and your monolithic application is that you're typically putting your services into applications. So when a functionality is required, you make a microservice out of it. And the difference between the two is that on a monolithic application, if you have like the example that best described it for me was if you've got 10 million people trying to sign up, but no one's viewing stocks, for example, then it's just the sign up process that you need to get instances of rather than an entire application. And that's where the difference is with microservices. You can initiate multiple instances of your microservices, and they can work together, and it round robins requests to them through console. So to get this project working, you'll probably need to read the README, but you'll need to run Kafka. I'm doing this on a Linux machine, so you need to be running Kafka. You need to be running Zipkin. It's up to you whether you run this or not. And you also need to be running MongoDB in the background, or MongoDB installed. You need to run console as well. And then it's the core applications, and I need to update this because beer tab no longer exists. So I've taken that out of the equation. So that's Kafka. That's console, I think, there. And that was Zipkin. That's beer waiter, beer stock, beer billing, beer front, and front end React, which is there. So what are these applications now, or what are you looking at as such? And to import all of this, you'd use IntelliJ and point to this file, and it will import the entire project. So this is your beer solution split into different applications. Stock contains what is in stock, and it's the raw stock with prices. So we'll go through all these in a minute. Billing is the back-end billing application, which typically bills for a beer. Waiter is the bartender that serves the beer. Beerfront is also, these are all microservices, and they run on random ports. 1, 2, 3 of them run on random ports, so you can initiate multiple instances of them. Front is a gateway application which has a client to all these applications and sends the traffic onto wherever it needs to. Front end React is your actual UI front end, React.js front end, and this interacts with this application. This runs on port 8080 and is physically bound. This runs on port 3000. So you can't have multiple instances of this and this running together on the same machine. You'd have to scale it out through multiple instances, virtual or physical. Point it to a host name and then round robin them through some other resources. So what actually happens is that this project was taken on from Mauricio over here originally, and I've sort of expanded on it and made it into something playable, which can be imported into IntelliJ and used that way. Billing, so let's work out what happens. So the front end sends traffic on port 8080 to Beerfront, which is the gateway. Gateway has the client to all these applications and then decides on what bit needs to go where and sends the traffic, routes it to that. They bring back the results, which goes to front and comes back to React to the user. So beer stock is configured to on random port with console and MongoDB. In the Java folder, micronaut demo beer, there's a domain folder. Beer cost is the beer name, bottle cost, pint cost, and that's your raw factory cost, and this is held on MongoDB. Beer stock is the name, bottles, barrels. The available pints gets worked out from barrels, which is according to that formula. And add bottles and stuff is there to basically decrement values when stock is sold. That's onto the DB. Now, the MongoDB that's running on this application beer stock is obviously, as you saw, pointing to that conf to MongoDB. Sorry. Where am I going? DB config. So beer stock is a table and cost, and sorry, that was the right file I was looking at originally. This is your Mongo localhost 27017. In your production environment, that would be a Mongo cluster rather than a singular host, because the reason is if you initiate multiple instances of beer stock, you don't want the failure point to be your single point or failure, which is the MongoDB. You want your Mongo to be able to be resilient, which is why running it on a cluster. And they would all, whichever instance is called or triggered, would be writing to the DB or calling the DB or whatever it works. And then they all read from that for the stock. So beer stock does some interesting stuff. It has a controller, stock controller, which attempts to locally look up those objects through the MongoDB, the beer stock and the beer cost. Also goes off remotely to markup controller, which sits on beer billing application and gets the markup cost. Now, markup is something that exists on beer billing and it's configured on there to say, when we sell a bottle, how much percentage should I mark on top of that? And the application at the moment has got only one markup, but you could base it on the happy hour markups, whatever, you know, it could be different rates for different hours or whatever. And it gets the rate. So once it's got the rate and it's got the cost and it's got the biz, it uses zip, which is a RxJava way of going through or looking inside the objects, which you can't at the moment. And inside those objects, which gets converted to these, which is the real objects here, it binds it together and returns the values of this map, which is a list of stock entity. And stock entity is a new object class that I've created, which maps all the objects of this, and this, the calculation of all this together. So we'll have a look at it, and we can see here, puts E and result 3 together. So E and result 3. So when it runs updates, so when it calls it originally, it just sets the base objects, and once it's set the base objects, it does an update which does some calculation for you, and it works out some of the costs. But what's actually quite interesting about this whole stock controller is, obviously at this point it's called a markup controller client. Now, markup controller client attempts to go off to billing and look at the markup controller and return the results for base costs. Now, if it's down, it says, okay, well, it's down. So I'm going to override it with a fallback rate of 8.16%, which is a hiked up rate, but sells the beer, even though it can't rate it. So rather than having a full system down, we've got something with an emergency rate that we apply at that point. That's assuming beer billing is down when stock is trying to put together a list of stock. So that's one of your fallbacks happening there. And it's within, obviously, where stock is trying to produce that list. Now, that's really what a beer stock does. And it also has, well, there's a few more things going on with it. As part of the startup, obviously, it puts all those things together, the costs and the stock names. If stock was to be down, it has a Kafka listener, which listens in for these topics. And these are when, assuming stock went down at the time that someone bought a beer, those increments are applied after the stock application starts up on its own, so long as you've got Kafka running. Okay, on Kafka itself, so this is another thing I've not really mentioned, and you'd have to go and look into it, but Kafka is clusterable as well. You can have a cluster of Kafka servers, and so is Console. So all of these technologies is designed for you to put them together in a resilient way so you don't actually get them to ever go down. Okay. I think that's the most important part that stock does. That's what it puts together a list, which puts together a markup from beer stock, beer billing, and it also receives from Kafka transmissions when the application was down if there was anything awaiting for it to be decremented from stock. The awaiter is the sort of waiter, and it has some important tasks that it does. So in the configuration, I've left two configuration files. You've got the application.properties, which does random port here again, console again, and the application YML, which binds in with that, and it also has Zipkin and Kafka enabled, which I think Kafka was in here already. No, it's not. Okay. But you could just replace all of that to this way. It's up to you. The way it's done it. Save me. So, what does be awaited do now? It hasn't got any domain classes, so there's no MongoDB on this one. It has an event publisher and a listener. Now, the listener listens in for when two things happen. When someone buys a beer or someone asks for the bill. I think the bill I've actually disabled, so this actually doesn't actually ever happen. But the beer does happen, and the beer basically calls ticket controller client, which is beer billing and attempts to serve that beer, which beer billing basically works out the costs of that beer, or puts together, it's got a map inside it that contains what beers has been sold to which user. And originally the beer billing was just a single map that contained a list of what beers were sold to which users. It's doing a bit more than that at the moment, but it's still relying on that core component because I've not really changed it to work out some of the calculation. So what's interesting again about that is that in a client, the ticket controller obviously attempts to add a beer, but if it's down, it calls no cost ticket, which implements ticket controller client. If it was down, it pushes that to a Kafka stream, which then when beer billing comes up, that has a listener and picks up this. Okay, so this is about having intelligent fallback that routes the information correctly when things have gone wrong, just in case things go wrong. And we'll show you all of this in a minute. So the event publisher is that thing that I've just shown you, which is when ticket controller was down, it calls this to register a beer registered event, which beer billing picks up. So the listener listens in for it and attempts to sell it or send it to billing. If so, go back to that folder again. But if billing is down, which is the ticket controller, it goes through if it's there. If it's down, just to be clear with you, it calls this event publisher.tab registered event, which is this other file. So that listener then ends up calling this if billing is down. Hope it makes sense. So that's beer weight, and also, well, it's kind of like it just does the legwork. It sends the things to ticket controller. It's a bit ticket controller, which is beer billing, and billing does the work and sends it back again, and that sends it to the beer front, which sends it back to the user. Okay, so that's beer waiter. Did we do billing? We haven't done billing. Billing again has MongoDB, so same thing applies, that you'd have it in a cluster and it'd probably be a different cluster to the other one. It may be the same cluster, I don't know. I don't think this is used, but the files are in those configuration files I've shown in the main classes. There's Trace, Zipkin, and Kafka. I think again. Now, billing. As billing starts up, sorry, let's go back. Billing has two domain classes. So that's the configuration files I was talking about, and that's the database names and the tables. Beer markup is, as I said to you, how much they want to charge on top of a bottle, pint, and the name they've given that markup. Cost sync is a very simple class that contains a list of the user or the person that's buying the beer and their current costs. So it just keeps doesn't collect what beers they bought, it just collects what their total is at any point. All of that is calculated in a ticket controller. When it adds a beer, it does all this cost sync, get the current cost, and adds it on to you know, updates the DB or saves it, depending. So the core work that's being done by the billing application is this, and it obviously does one other thing, which is it serves markup back to the stock controller, which is this controller here. It has Kafka, and it listens in obviously for that beer registered event, and it does this long-winded way of doing what ticket controller is actually doing. So I think I was just messing around, or I couldn't get the ticket controller client to work. I'm not sure what was going on at the time. It was probably me rather than the process, because the process works and I've done it in other places. But I've simply redone the work that the ticket controller does in here, and it just simply appends a beer to the customer when it receives it through Kafka. And we'll see all of this in a minute. I don't think there's much more to it. Obviously, the services are used by the controllers to calculate things out, and that's really it. That's really the billing. So let's get going. Let's test this out as such. Probably get rid of all this. So first of all, I've done this video a couple of times, but I've decided to redo it again simply because I suck at this, and I did a really bad job at the last one, and I didn't explain things properly, and it probably makes sense to redo the video because, well, probably makes sense, doesn't it? If I haven't made sense before, it makes sense to make sense now. Because I know what I did wrong, and this is the bit that I'm going to explain, which I didn't do properly before because I assumed people understood things. But when I thought about it, I thought, well, only I understand it, but maybe a lot of others won't understand what I'm trying to get to. So, this is the beer solution or the beer shop. I'm going to log out. Stocks. This is what comes back from the beer stock application, and it comes to the beer front application, and gets sent to beer the front end UI. And I think I haven't actually gone into that bit, and maybe I should just before I go into it. So beer front has console, and it's bound to port 8080. It's called Gateway. It also has Kafka and Zipkin. It has Event Publisher, which is used for well, everything. Anything that goes wrong is published, and that's done by this new simple beer option. And then we go through that, and this is the whole reason why I've redone this video. So hopefully it will make a lot of sense when we get there. And it has a controller, gateway controller, which binds into stock controller client, waiter controller client, stock controller 2, waiter controller client 2. And in a real world, you wouldn't have this. This is demonstration purposes only, just to show you when you do things intelligently, things will work. When if you do things your own way, you end up suffering. So I'm going to talk through what I've done and how I've got there and why I've decided to go around doing it this way. So this is beer to pints to half pints to bottles to build to, and that's used by this interface. And all of the rest above are used by the normal, so they're calling the waiter controller 2 clients and the stock controller 2 clients, whereas the bits above are calling the waiter controller and the stock controller client. The difference between the 2 clients is their routing for their fallbacks. I've just left it there purely for demonstration purposes because I had gone down this route originally, this one here, and then after looking at all the overheads, I've decided to go down this route, and I'll explain why. So in the clients, you've got stock controller client 2 and stock controller client. They're typically the same. Stock fallback is the original, which simply returns nothing, just, nothing. It does nothing. Whereas stock fallback 2 uses the event publisher and publishes not these bits, because that's just getting the list of stock which is out of stock, but if it gets increments for pints or half pints, it calls it event publisher and pushes them to Kafka, so that when the application is back up, it picks them up and decrements the stock. And waiter client fallback 2 also, again, has an event publisher, and it publishes a beer registered event. So to say, when waiter comes up, send that to waiter, and then waiter will try and send it to billing. If billing is not up, it will send it to the stream, which will wait on Kafka again for billing to come up. And when billing comes up, it gets that. So that wraps up all your, process or flow of information. And beyond that, there is nothing more in that application. There is one more application, which is your actual React.js site, and this is just the JavaScript site, which in the config there's the URL which it connects to do all the REST calls, which is that beer front application. As you saw in the application properties, it was bound to port 8080. And so in beer there's an index.js, sorry, app.js, and here they get defined. And then they get bound here and shown as options on the page over here, and they get bound to the objects, and then the objects are here, and then so index.js starts it up and does all these calls to beer 2 pints, 2 whole pints, 2 bottles, 2 bill 2. So this is that new method, and then this loads various different things into stock table, which is another page. If the user's not logged in, it asks them to log in, which is just a vuex session for the username. There's no actual authentication. Stock table loads a table which gives a navigation bar of the current user's bill and ID of the desk, and the waiter ID, which is the ports of the applications. A logout button, and also then tries to load stock row, which stock row attempts to load in the options, these things, and the icons that you click on. So that's all driven by this. And there's a more complex version of this in beer, which you can happily follow and try and keep up with. There's also a health check, which gets bound to beer, not beer 2. And this is part of my talk, or what I'm trying to outline, why I've decided to go the other way. And that's really the front end. So that's where we are with the 3000. So we're in the shop now, and what we want to do is we're going to start with stocks. It's got a default markup, and the prices at the moment is 15,279. I think I should launch Kate. So we can keep track of what things are at the moment and what the prices are. Just look at this one example here in the costs. What we want to do now is now, assuming this is our application running, but it's all in different bits that interact to make it one. So this is what microservices is. So assuming stock is up, which is here, we can see, and it relies on billing to get the markup, which is what we see here. If we kill billing, oops, what should happen is it will go to fallback, which, if you remember, was a different rate because, well, we don't have stock to give us markup. So you can see here, price has changed or gone up because we no longer have billing. That's fallback number one explained. So I'm going to start billing, and I'm going to also start up another billing. I'm going to start up another waiter if it allows me, and all goes well. I'll wait for this one to finish because it yeah, it's finished. Yeah, it's just altogether I think they hammer a little bit more. Just give it a little bit of time and it's fine. So we've got now 2 instances of waiter running, 2 instances of billing, a beer stock, beer front running up there, which we can only run one instance, and the React front end on port 3000. My machine's running really slow, so I hope I can do this. Oops. Buy a beer. So these are the desk IDs that I said to you, the ports. So if you refresh, we should end up with different ones. 33235 26902. Doesn't really, we don't need to write this down. Here we go. Got a different port there already. So that shows you it's going to different instances of the waiter at this point. Anyhow, so what I did originally was this version of the application, which, as you can see, it's got this health check or stock up, waiter up, and milling out. And what was the point of these things now? Well, that was for me to say, well, let the front end decide on what should be displayed based on what the back end is. Yeah, right. So quite cool to have a feature like that. So let's kill billing and see what happens. Refresh the page. It's gone green. It's decided at that point that the billing application is down, so I'm not going to no longer show you that option, but I'm going to show you a different option. Great. It's a great feature, yeah? I thought that. Well, great. And you can see all that in sorry, it's in front end React source here software. And it's this load dynamic which works out is waiter up, is billing up, and the colors you can see success primary, and that's what's the blue and the green, and that's going to tab, or it's going to buy, beer tab or beer buy. And beer tab is just basically to send it to the Kafka stream. Now that is all great, but the problem with something like this is, well, first of all, I've had to refresh to capture that. So if I was in the midst of the process of doing something, or assuming it is up, so I'm going to bring it back up again. And we'll wait for it to come out. But assuming it is up, and I'm not going to be as a user. I'm not going to obviously certainly not be refreshing it. I could have WebSockets in the background doing checks to see when applications are down and notify these checks and change buttons on the fly. But assuming I've done this and I've just clicked it, as I've clicked it, the application's gone down. You know, and you're never going to be able to capture those millisecond things that are critical when you've got that flow of information happening. So to try and do it this way, all you're actually doing is adding lots of overhead and it's not necessarily that you're actually ever going to capture it at the precise time when a user clicks something that something has gone wrong, and to be able to do something good with it. So you're better off forgetting all of this and going for this simple beer option, which I'll explain. So the problem with buy a beer obviously is, first of all, the logics of this is too reliant on the waiter. Okay, because if I kill waiter, so this goes back to how are you configuring or writing your microservices to work and your front end to also work. So with waiter down, waiter isn't around. I can't help you. The shop is down at the moment. I could go for this, but the waiter's actually down, and that still goes for waiter. So that button that just simply doesn't do this check, and this will fail because this is going back to waiter client controller client 1 or waiter controller client, not 2, which is simple bid goes to the second. So we'll show you all of that in a minute. I'm going to start up another instance of waiter. I don't really want to run 2 instances of billing and waiter together. There's nothing to show it works, it just sends it to either one or the other. That's not what I'm focused on here. I'm focused more on about the process, the flow of information, and making something happen when things go wrong, and making sure that thing actually happens. So the shop should be back up again, and buttons have gone blue because billing is up. So if we buy something, we've got a bill, we've been served, everything is working there. So I'm going to go to the other solution now, which I think this one's covered now, and I think there's not really a lot more to say about it. I could show you actually, let's just show you quickly. So balance of 185 if I buy, so let's take billing down. When we take billing down, the prices will change, obviously, if you remember. So this is what it is at the moment. Right, so we take billing down. This is something that caught me out in my first video of this, so I'll make sure I do it properly this time. So with billing down, we can see here billing is down. Price has gone to 0 because we can't get billing, and we want to buy 5 more bottles. And if you look at the cost, it's gone up, and that's the amount of bottles. So we're going to buy 5. There's 380 available. Cost has gone from 15.28 to 24.40, and we're going to go for the green button, right? And if we now bring up billing, and our bill was 185.69. Stock should go down to 375, or it should have already gone down because stock was still running. But my bill should have gone up. There we go. I bill £328, which is the marked up price now being charged at 24.40 for the 5 bottles with the VAT. That's what it's worked out to be. So that wraps up the more complex version. Now I'm going to go to simple, and I'm going to log out and create a new user. JJ's got a balance. Wow. PP's got no balance. So let's do some funky stuff. PP's going to buy 1 bottle. Gone up by 17.88 with the VAT and 15.28 bottle. Quite expensive beer for Heineken, but hey, he's paying. So what we're going to do now is we're going to kill waiter. Waiter's just disappeared. We'll refresh the page. Everything looks fine. Actually, we're not getting the bill because waiter goes at the moment. Waiter's going to billing to get the costs and set up The process goes to waiter to get the bill, but the bill goes to billing to get to, yeah. Anyhow, so because waiter's down, we're not getting any costs. We're going to buy, but billing is up because the costs are normal. Do you see what I mean? Yeah? It's able to mark up correctly, but waiter's down, so you can't get the bill. So we're going to buy one, and what was it before? Let's just bring it up before I do it because I'm a little bit confused and I don't want to run off and be confused even more like last time. So it's up. What's up now? We haven't bought anything yet. Well, we bought that one beer, didn't we? 1788, right? So this is our current. Alright, so we're going to kill waiter. And we've got no bill, but we're going to buy one bottle at 15.28. Bottle count's gone down, nothing on the price. Going to bring waiter up. On the beer application, on the original buy beer, this would have no longer worked because waiter was down. But waiter has now got a Kafka stream, and when it comes up, it forwards everything back to where it should go. So we should, at some point, there we go. So as you can see here now, we've gone from 1788 to 35.75 and 374 to 373. So if we, okay. So, well, it's not giving us the rounded, but that is that times 2. So it was sold it at the same rate, and that's what we got. So now let's do some other funky stuff. Let's kill waiter and let's kill billing. So all we've got now running at the moment is stock, front end, React, and beer front, and obviously the Kafka and the console and Zipkin, which I haven't even shown you yet. So still running. We've got no balance, and stock is up. So we're going to buy, but the cost has gone up now, right? Because billing is down, so it can't get the markup for stock, but stock is there. So it's giving us the emergency fallback rate at 24.40. We're going to buy 5. Obviously, the stock's decremented, and the price of that was that. So, does it matter which order you bring up the apps? Not really. You choose, because the process is there's also another Kafka stream inside those apps to say, well, if that app can't connect to the real thing, then send it to the next stream, which then the real application picks up when it comes up at its own time. So does it matter? Not in this instance. So if it was up before, it would have sent it directly to it. If it was down, it goes to the Kafka stream and then it picks it up through Kafka. So that's what would happen. And over here now, some point when it gets picked up, there we go. So stock has obviously gone down, but our balance has gone up from £35 to 178 because we bought 5 at 24.40 plus the 35.75, and that's what we got now. The stock is 368. Now, for my next bit of the video, or the next part of the video, what I wanted to do is go really crazy. We want to kill, so first of all, log in as BB. BB's got a nice bill. Right, so BB's logged in, and I want to kill billing, I want to kill waiter, and I want to kill stock. So all we've got up and running is the front end React and beer front, which is the gateway application. There's no actual real applications up now. All right. This is BB user. So if BB, this is what I needed to show you, which I didn't show you. If BB goes to buy a beer now, it's out of stock. If PP isn't aware of that and decides to buy 5 bottles and the cost is still that because it's not refreshed, it thinks everything is up and running at that point because that's what the user was on. Remember, this is what the user's just hit now because applications are down. This is what the user was on when they're about to click it. And this is what my whole purpose of the thing about doing the health check is pointless because look, I'm going to hit it now, but I'm going to get that now. I should really get here some message saying, thanks, we're processing your order. There was a problem temporarily, blah, blah, blah. Now watch what happens. We're going to, again, I don't think all the matters. Did we record down what it was? I think it was 368 left. Okay, everything is up now, hopefully. So the stock has definitely gone down from 368 to 363 now. The rate's still 24.40 because it thinks billions down. It's billion now. So okay. So has the balance gone up? It certainly has. So what you can see here is that even though I killed every application that was every microservice out there, we still managed to get that bill through and we've still managed to get the stock down. And if you wanted me to show you again, I can do, but you can just rewind and play it again. If there's no magic tricks there. Yeah, obviously you can download it yourself and mess around with what I've just talked through. Now, some of the other things that I wanted to talk about was as part of this, you get what's that for then? For 100, 9411. I keep on doing that. So you get a zip kit, which if you've got running, and that gives you your calculations of what went where and what happened, which applications it went to, how long the times was. I mean, that looks ridiculous. 2 seconds. So you can look through every sort of transaction. I'm not sure why it's probably to do with the way of label thing. You can, yeah. So I found that through here I was getting a lot of health checks, I think from the status, and from that I decided to go about the whole entire process of doing the health check in a different way. It started off as the front end React hitting 4 different controller actions, which were billing status, rater status, stock status, tab status, stab status. And basically, they went off and did a lookup against the clients, which just returned as simply a status code of 200. Well, sorry, it attempted to just look up a successful status code from the HTTP response as such. So if you look up It'll probably make more sense if I showed you. Only if I showed you it would make sense. So much sense. So that's a client who goes off and gets a response, and the actual controller is in another application. Over here somewhere is. Oh, this will do. This will have it. No, it doesn't. I don't think this one has it. Ah, what's going on? How can you do that? What? So I'm gonna stay here. What's that stay? Oh, it does that stay. So it just returns HTTP responsive OK from the actual application. Now, what all it does is, if there's a problem, it goes to the fallback, which the fallback says, hey, you know what? Just return that as a error. All right. So that's all it was doing. But really, there's a lot of work happening. You know, every time you triggered those pages, it was going off and doing 4 different requests to the gateway. The gateway was then going off and doing lookups on the clients. The clients were saying, hey, I'm here, or oh no, I'm not there, or whatever it is, and returning a fallback or the actual client response, which is going off to the remote application and sending it off again. You know, so a lot of things going on there. And I tried to, first of all, correlate all of them to go off and do it in a map and return that as a response like this over here. But then again, it's still repeating all that work, you know, it's still all the client lookup. So I've been thinking about this and I thought, well, actually console is doing exactly what I'm trying to do here, because it's got a list of all the healthy nodes inside it of each application. So first of all, it gets all of the client nodes, client names, which is in the application properties, that get name of the application. So in case of gateway, it's called gateway. So that would be what's registered on console as a name, and it gets all those names and it collects those names. It then looks up through the healthy nodes of console, and if it finds an healthy node, it adds that in to the healthy nodes array over here, which is just a list of the string, and that's just the name that it found from up here, it puts into here. And then it says here simply, if that array list contains the name billing, make it 200, otherwise 400, which is what that status check was doing previously, typically. But we're not going off to each application now and looking them up, because we're relying on console to tell us what it thinks is healthy. Since it's done all that legwork for us already, you know, why do it again? So now the health check that's happening on that first page, primary buyer bidder, is really using console technology to work out what's healthy and what's not. But fundamentally, it goes back to what I was saying to you, which is you're here, the user's about to click the button, and you have to capture that you've taken the stand, and you've taken the stand, and you've taken the stand, and just before the user clicks the button, you've got to capture that. And then what happens if the user's just clicked it? How do you change the button and make it do something else? You can't. So you are better off attempting to do something properly, which is let's make it work however possible. And that's what's happened with the simple beer. Simple for the user, more complex to put together, but overall gives you a clean solution that delivers when things have happened. I hope you've enjoyed this video. I probably have rushed through a few things. If there's any questions, leave comments, or go to the project, and I'm happy to discuss things with you on there if you need to. You can raise issues somewhere on here. Somewhere on there you can probably raise issues. Oh, I can't remember. I can't remember how it was done. Anyhow, best of luck. I hope you enjoyed it. Bye bye.